Welcome back, guys, to another exciting trig lesson. Today is the first day of the rest of your life, guys. We're going to look at how to graph a trig function on an xy coordinate plane. Not like graph a trig function on a unit circle, not like SOHCAHTOA or anything like that. Like I'm talking xy coordinate plane. So to graph a trig function on a coordinate plane, first off, you're going to need access to a unit circle so that you know some values on here. And we're going to find very specific values on the function that are easy to plot. Because if you look at your unit circle, there's a lot of x and y values on here, but a lot of these do not look fun to plot. So we're going to avoid the majority of these, and we're going to pick very specific ones that are easy to plot that come from our unit circle. So the first graph that we're going to look at, what it looks like, y equals sine of x, just the basic parent sine function. So our input, like our x values, are going to be theta. Basically, we're inputting different angles, and these are the angles that we want to memorize to use these key points, because these are the easiest ones to find on the unit circle. So I'm going to go take a peek at my unit circle and find the sine value at the angle 0. Okay, at angle 0. You'll notice here, remember, the cosine is first and then the sine is second. So my sine at angle 0 is 0. Okay, and then I'm going to go look at pi over 2, which is a 90-degree angle. At this 90-degree angle, what is the sine value? It's 1. And I'm going to go look at pi, which is a 180-degree angle. At 180 degrees, the sine is 0 again. Pen is dying. I'm going to have to switch to pencil. Okay. At 3 pi over 2, 3 pi over 2 was like a 270-degree angle. That's down here. So remember, first number is cosine, second number is sine. And then back again at 2 pi, which basically is coterminal to a 0-degree angle. The sine again is 0. So I'm going to take these little guys and I'm going to plot them on my graph so that we can see what this looks like. Let's graph in green. Okay, so starting with 0, 0. Okay, and notice how I've adjusted the x-axis to fit like some nice looking numbers here. Like obviously if you just counted by 1, 2, 3, and 4, that would be a little tough because then you'd have to figure out where pi over 2 would fit. But I'm going to plot 0, 0. So on the x-axis, 0. On the y-axis, 0. There's our first point. Okay. At pi over 2, we're up at a y value of 1, which I'm going to probably need to label. I'm going to make this number 1, and then I'm going to make this a 2. So then this would be negative 1, and this would be negative 2, although it really doesn't matter. Okay, so at pi over 2, we're at 1. Pi over 2, we have a point at 1. And then at pi, we're back at 0. Okay, at 3 pi over 2, we're at negative 1. And then at 2 pi, we're at 0 again, which is right here. Now, if we connect this, you'll see it's going to create a very unique looking pattern. And this unique looking pattern would actually continue on with this same pattern. Okay, meaning that when it continues this way, it's going to have a point down here at negative pi over 2, negative 1. And then at negative pi, it's going to be back at 0. And at negative 3 pi over 2, it's going to go back up to 1. And then at negative 2 pi, it's going to come back to 0. And then it's going to just keep on going with this cycle over and over and over. So starting with some vocab words, talking about what a cycle is. A cycle is one period of a function. So first off, you're probably thinking, what the heck is a period? A period is basically where it creates like the little design where it goes up and down and back up to 0 again. So all the way from here to here, 0 to 2 pi is one period of the sine function. Okay. Period is the x distance that it takes to complete one cycle. So you can see one full up, down, back at 0 again is one period. So then this part of the graph where it goes up, comes back down, and then goes back to 0 again, that's what's called one cycle of the graph. One cycle. So sine functions are what are called periodic, meaning periodic graphs like literally create the same pattern over and over and over and over and over. Next part, frequency, the number of cycles completed in 2 pi. So this is 2 pi right here, and only one cycle of the sine function was completed in 2 pi. And then next new word is going to be amplitude. Amplitude I kind of think about as like the height of the graph. So the amplitude on this one is actually 1, but the technical definition for amplitude is the distance between the midline and the maximum or minimum. The midline is literally the middle line. This is our midline right here. Okay. So the distance between the highest and lowest is called the amplitude. So the amplitude on this one would just be 1. It just has basically a height of 1. I'm going to write in that was called the midline. Okay, so filling in some information about this, the domain of this graph, it does go left and right forever. It's going to go left forever, right forever, which means just like we're used to, domain would be negative infinity to positive infinity, not including either one. Our range remember is lowest to highest, which remember lowest would be right down here at -1, highest would be +1, and both of those are included, -1 to +1. Okay, the period is the distance it takes to create one cycle of the graph. So for this one, the period is a distance of 0 to 2 pi, which would just be 2 pi. So it's the x distance to create one cycle. The amplitude, remember, is kind of like writing the heights. For this one, it has a height of 1. And then last up, the frequency. The frequency is just the number of cycles that's completed in one period. So in this one period right here, there was only one cycle. And this is the parent sine function. We will be creating some transformations of this parent sine function, but before then, let's look at what the parent cosine function is. Okay. So both sine and cosine functions, again, are called periodic, meaning a function that repeats in regular values, periodic intervals with its graph exhibiting the same pattern at fixed intervals. So like the cycle where it goes up, down, it's just going to repeat over and over and over and over. So next up, we're going to look at the parent cosine function. Again, using those same input values that we called our key points, although the output values for cosine are slightly different. Okay, so starting with at an angle of 0, what would be the cosine? So back to my unit circle. At an angle of 0, my cosine is 1, because remember it's cosine sine. Cosine is 1. At an angle of pi over 2, that's a 90-degree angle, our cosine would be 0, because the first number is the cosine. At an angle of pi, which is 180, our cosine is -1. At 3 pi over 2, 3 pi over 2 is the 270-degree angle. Your cosine is 0 here. And then back to 2 pi, a full 360 degrees around, your cosine is back at 1. So just like the last one, I am going to create a little graph of this so we can see what this one looks like for the parent function. So I'm going to label the y-axis just like I did on the last one. 1, 2, -1, -2. Okay, so at an angle of 0, that's the x-axis input. It'll have a cosine value of 1. At pi over 2, it's at 0. Okay. At pi, it's at -1. At 3 pi over 2, it's back at 0. And then at 2 pi, it's up at 1 again. So you can kind of see how one cycle of the cosine graph looks slightly different than one cycle of the sine graph, although it does repeat the same pattern over and over and over. One cycle of it looks different than it did for sine. If you go back and look at what the sine looked like, the sine started at 0, went up, came back down, and then goes back to 0. Whereas cosine starts high and then goes low and then comes back up again. And again, just like sine, it would actually continue if you went more to the left. So at negative pi over 2, it would be back at 0. At negative pi, it would be back down at -1. At negative 3 pi over 2, it would be back up at 0. And then at negative 2 pi, it would be back up at 1. And then it will just keep going. This is called periodic, where the same pattern repeats over and over and over and over again. Okay, marking off the same stuff I marked off on the last one. One period of the function would be the x distance in order to complete one cycle of the graph. So this is one period, which would be a distance of 0 to 2 pi. Okay, your one cycle of the graph, the cycle looks where on a cosine function it starts high, goes real low, and then comes back high again. That's what one cycle looks like. One cycle. Okay. It does have the same midline as the sine function. The midline is going to cut right down the middle. Here's our midline. Okay, so marking off the same information we did on the last one. The domain of this, just like the sine function, is still left and right forever, which means negative to positive infinity. Okay, the range on this one is also the same as what it was for the sine function, because the lowest is -1, the highest is +1, including both of those. The period, remember, is the x distance it takes to create one cycle, which would be from 0 to 2 pi. So that distance is just 2 pi. Amplitude, remember, is kind of like the height of the function. The amplitude on this one would be from up to 1. It's the distance kind of between the lowest and highest. And then the frequency would be how many cycles are finished in one period. How many cycles? That was just one cycle. Okay, we're going to throw in, come on, what's our frequency? We're going to throw in just some baby transformations on the back just to kind of get us started with transformations. Obviously, the transformations do get much more complicated, but we're starting out really small. Just talking about how the period and the amplitude can change first. So if we're working with a small transformed function, so this transform function would only have a change of this a value in front of the function and then some sort of b value inside the function. How we've referred to these before, when you have a number in front of the function, that causes a vertical stretch. It can also cause a reflection if it's positive or negative. And then the b value inside the parentheses, we have referred to this as a horizontal stretch before. And that can cause your graph to stretch out this way or squish in this way. But on a sine or cosine function, it changes the amplitude or it can change the period. So looking at how it changes the amplitude is just going to be the absolute value of a. And then to calculate the period of the graph, we'll do 2 pi divided by the absolute value of b. So first thing we're going to start is just to look at how the amplitude and period changes for a couple of them without having to deal with their graphs. Okay, so starting with the first one, I can see its a value. Here's the a value, but it does not have a b value. There is no number inside next to the x. On number 2, I can see the a value, and then my b value is here next to x. And then on number 3, here's my a value, and then my b value on the last one is actually 2 pi. That's the coefficient in front of x. Okay, so starting with my amplitude for the first one, my amplitude is going to be the absolute value of a, which would be absolute value of 2, which is just 2. And then my period is going to be 2 pi divided by the absolute value of b. So for this one, it would be 2 pi divided by absolute value of b. On this one is actually just a 1, which is just 2 pi divided by 1, which is a period of 2 pi, just like the ones on the front. So this period did not change. For number 2, the amplitude would be, again, absolute value of a, and then absolute value of -3 is 3. So this one, if you think about it, it's basically getting stretched taller. So like the highest point wouldn't be at 1 like it was on the front. The highest point would be at 3 on this one. And then the period would be 2 pi divided by the absolute value of b, so 2 pi over 4. And then this actually does reduce. The 2 over 4 would reduce to pi over 2, which basically means it would complete one full swoop up, swoop down sine function in a distance of pi over 2. So it would kind of be like squished in further together. And then for number 3, its amplitude, absolute value of 1/2 would just be 1/2. So instead of going up to 1 like these do on the front for the parent function, they would actually only go up to 1/2. So they'd be kind of like shorter. And then our period on this one would be 2 pi over absolute value of b, which is also 2 pi, which is just 2 pi divided by 2 pi, which is 1. So this one would complete one full cosine function where it comes up, goes down, and then goes back up in a distance of 1 unit. Okay, so now that we got that down, we're going to actually practice graphing a few little baby cosine and sine transformations. Sorry about the camera, I was trying to put my legs up. Okay, so we have done transformations before, and I'm going to actually teach you this lesson the same way we did transformations before. The way we did transformations before, we've done it a few times this year. We talked about anything that's outside of the parentheses is going to affect the y values of the points. Anything that's inside parentheses, like if you had a b value, that would affect the x values of the points. So this one does not have a b value, so I know that this one is only going to affect the y values, and it just affects them straight out. Whatever number you see here is what you're going to do to your y's. I'm going to start by calculating my amplitude. Let's mark our A. We don't have a B on this one, which means B is just 1. So our amplitude is going to be absolute value of the A, which is just absolute value of 2, which is 2. The period is going to be 2 pi divided by our B value, which again is just 1. So it has a normal period on this one where it goes from 0 to 2 pi. And then I'm going to start by writing down the parent function points for the cosine function, which if you haven't memorized them yet, we do have them on the front. 0, pi over 2, pi, 3 pi over 2, 2 pi. 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And then for the y values, remember it starts high on the cosine function and then it comes down low. So it goes from 1 to 0 to -1 to 0 back up to +1. So it starts high at 1, then goes to 0, then goes to -1, then starts coming back up to 0 and then up to 1. So it starts high and then goes low. Okay, so according to this, we have nothing that's going to affect the x values of our point because we have nothing inside the parentheses. But we do have a number that's going to affect the y values of the point. Anything not in the parentheses affects the y's. So my y's, all of my y's, are going to be times 2 according to this. So I'm going to go through all my original y's. All of them are going to be times 2. Okay. So my x's are not going to change. I'm going to take them and transfer them over to my transform function. 0, pi over 2, pi, 3 pi over 2, and 2 pi. But all my y values are going to be twice as big according to this. This is technically what's called a vertical stretch. 2 times 1 would become 2. 2 times 0 would become 0. 2 times -1 is -2. 2 times 0 is back at 0, and then 2 times 1 is +2. I also left the scale empty on these so we could kind of adjust them ourselves. So you can see on the x-axis, we need everything from 0 to 2 pi. So I'm going to go ahead and mark those off. I'll put pi here. I'll put 2 pi, which is just twice as big. Here will be half a pi, and then our 3 pi over 2. And then our y-axis, we need the highest to be 2, and then the lowest to be -2. And then we can plot our values, and we're just plotting one cycle of this graph, which just means one full up, down, up again. You don't have to draw like several like we did on the front where we had the one that went up, down, up, and then another over here, up, down, up. So we're just doing one cycle. Okay, so we'll have a point at 0, 2. We'll have a point at pi over 2, 0. And then at pi, we're at -2. At 3 pi over 2, we're back at 0. And then at 2 pi, we're back up at 2 again. And you're going to do your best to make it look like this, or better than this. Probably better than that. That's a terrible looking graph. There we go. So even though we're only graphing one cycle of this, remember it does go from -infinity to +infinity. You can see the amplitude is 2 because that's the distance between the midline and the highest point, or the midline and the lowest point. you can see that it did one cycle in 2 pi, which means like one full swoop where it goes down and back up again in a distance of 2 pi. All right, next one has even more transformations. Next one is a sine function. Okay, -3 sine of 4x. I can see my a value here. Remember, an a value is a vertical stretch, and it's negative, so it'll be a reflection. They'll be upside down. And then I also have my b value here. Okay, anything that's in front of the sine is going to affect the y's. Anything that's inside here, this would be technically inside the parentheses, would affect the x values. I'm going to start by calculating my amplitude, which remember was just absolute value of the a value, which would be 3. And then my period would be 2 pi over the absolute value of my b, which is 4. So that's 2 pi over 4, which then the 2 and the 4 would simplify to just pi over 2, which means it's going to do one full cycle where it does the sine swoop, up, down, up again, in a distance of pi over 2. So it's going to kind of be squished together. Okay, I'm going to start by listing out my original values. It has the same original x's, the same key point x's that the cosine one did. Remember, those key points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. But the y values are different for the sine function, because instead of starting high, going down and up like the cosine does, remember the sine starts at the middle, goes up, comes back to the middle, and then goes down and goes back up again. So its initial value, this would be 0 right here. Its initial value would be 0 for y, and then it goes up to 1, then it comes back down to 0. Sorry, that should be a 1. It doesn't look very 1-ish. Okay, and then it goes down to -1, and then it comes back up to 0. Okay, so now that we have the original values, we can draw our transformations in, or plot our transformations. So the one that's not in the parentheses, this -3 here, because it's not in the parentheses, this number is going to affect your y's. We're going to take all of the y's and we're going to multiply by -3. All of the y's times -3. Excuse the sound of my dog chewing her bone in the background. Okay, and then what's in the parentheses here is going to affect the x's, but it doesn't affect it directly the way it looks. If you remember how I originally taught you to think about this, I taught you to take what's inside the parentheses, set it equal to a number sign, and then solve for x. So to solve for x here, I would basically divide by 4. Divide by 4. So this is going to tell me what I need to do to my x's. I need to take the numbers and divide them by 4. Okay, so because a bunch of these are fractions, instead of taking these numbers and dividing by 4, I'm actually going to multiply by 1/4 instead. It's kind of like doing the same thing. Or 1/4 times your numbers. Okay, so over here with these x's, all of these we're going to multiply by 1/4. And then we'll figure out what our new values are. I'm going to start with my new x's. 1/4 times 0, that's still 0. 1/4 times pi over 2, top times top, bottom times bottom would become pi over 8. 1/4 times pi would become pi over 4. 1/4 times 3 pi over 2, that would become 3 pi over 8. And then 1/4 times 2 pi, that would become 2 pi over 4, which would then reduce to pi over 2. Which should make sense that this is our last x value, because remember our period is pi over 2, meaning it has to complete one full cycle from 0 to pi over 2. And then getting in my new y values, all my new y's we're going to multiply by -3. -3 times 0 is -3. No, it's not. It's 0. -3 times 0 is 0. -3 times 1 is -3. -3 times 0 is back at 0. -3 times -1 is +3. And then -3 times 0 is 0. So this is going to look different than our normal sine function that goes up, back down, and back up again, because it is negative. So all of these are kind of be reflected from where they are normally. But let's adjust our axis first. Okay. My x-axis needs to go all the way from 0 to pi over 2. So if you think about, like, normally, like, here's pi. Okay. Here's pi over 2, because that would be half a pi. So in between here would be 1 pi over 4. So here's 1 pi over 4, 2 pi over 4. This one would be 3 pi over 4. Okay, in between pi over 4 would actually be pi over 8. So here's pi over 8. Here's 1 pi over 8, 2 pi over 8. Then we'd have 3 pi over 8. And then lastly, 4 pi over 8 would be the same as pi over 2. I think that's all of them. Pi over 8, pi over 4, 3 pi over 8, and pi over 2. Yes, we have all of them labeled in here. And then on my y-axis, it needs to go from 0 to -3 to 3. So I definitely need to go at least up to 3. 0 in the middle, -1, -2, -3. Okay, so remember this one should look a little more squished because the period is so small, meaning it's going to do one full cosine swoop in a distance of one full sine swoop in a distance of pi over 2. So plotting these points, we got a point at 0, 0. We have a point at pi over 8, -3 down here. We have a point at pi over 4, 0. And then 3 pi over 8, we're back up at +3. And then at pi over 2, we're back down at 0. So again, this is just one cycle, which is like just one full up-down swoop. But this one, because it was reflected, it's going to start by going down, and then coming back up, continuing up, and then coming back down again. I'm just going to draw arrows to show that it continues. You can definitely see the amplitude of 3, the distance between the midline and the highest point, or the midline and the lowest point. At that amplitude of 3, you can see it squished in because the period was smaller, so it does only complete one cycle in a distance of pi over 2. All right, let's do one more transformation. Last one we're going to do is cosine of x over 2. So the parentheses on this one would be like kind of right here. And notice on this one there is no a value, which just means a is 1. But the b value on this one, you have to think a little clever. You have to think that that would be 1/2 times x. So this is 1 cosine of 1/2 x. So you can see your a value, and then this is your b value. Okay, so starting by calculating my amplitude, which is just absolute value of my a. So amplitude is 1, aka that means it just has a normal height on this cosine function. The period would be 2 pi divided by the absolute value of b, which is 1/2. So that's 2 pi divided by 1/2, which would become 4 pi. So it's going to complete one full cosine swoop in a distance of 4 pi, which is twice as big as it is normally. Okay, so I'm going to start with just my basic same key points that we had on all the others. We got 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and remember what the cosine function normally looks like to figure out your y's. It starts high, comes down low, and comes back up again. And then your midline is kind of here. So it's going to start at 1. It's going to come back down to 0. It's going to go down to -1. It's going to come up to 0. And then it's continue back up to 1. Okay, and then looking at what we're doing, how we're transforming the x's and y's, this one, because the a is 1, this just tells me that I need to multiply my y values by 1. But obviously, if you multiply your y values by 1, they're not going to change, so I don't even bother with that. To find what I do to my x values, I'm going to take what's inside my parentheses, 1/2 x. I'm going to set it equal to a number sign. It's more like just a placeholder, and then I'm going to solve for x. To solve this for x, I'm going to multiply by 2, which means x equals 2 times my number. So this is telling me what to do to my x's. I need to take all of these x values and multiply by 2. And then nothing changes on the y's because the a was just 1. All right, so my y's are not going to change. 1, 0, -1, 0, back up to +1. But for my x's, 2 times 0 is 0 still. 2 times pi over 2 would become pi. 2 times pi is 2 pi. 2 times 3 pi over 2, your 2's would cancel and you'll just have 3 pi. And then 2 times 2 pi is 4 pi, which should make sense because your period is 4 pi, so it should go from 0 to 4 pi for your x's. Okay, so I'm going to go adjust my scale. I need to go all the way over here as 4 pi. So then halfway would be, we'll call this 2 pi. Half of halfway, we'll call this 1 pi. And then halfway in between 2 pi and 4 pi, we'll call 3 pi. And then for my y values, I really just don't need to adjust it very much. My highest I need is 1. My lowest is -1. And I'm going to take these little guys and plot them. We'll start with 0, 1. Okay. And then we'll do pi 0. So over here at pi, we'll have 0. 2 pi, we're at -1. 3 pi, we're back up to 0. And then 4 pi, we're going back up to 1 again. Which, remember what the cosine swoop should look like. It starts high, comes back down, and then goes back up again. So we're going to draw in our little cosine swoop to the best of our ability. Draw your arrows on both sides to show that it does continue on. It is periodic. It would create that same pattern over and over and over. Alright guys, I hope you learned something today about graphing some basic sine and cosine functions.